Welcome to Collapsed Latents. This week in AI, where we cut through the noise and deliver the most transformative breakthroughs in artificial intelligence, distilled into one seamless, deeply technical journey. This week, we're diving into 5 revolutionary papers that aren't just advancing the state of the art, they're redefining what's possible. From real-time, cinematic video generation on a single GPU, to AI that edits images like a detective, asking the right questions before it even generates a pixel. No fluff, no hype, just the raw science, the clever architectures, and the fundamental shifts in design that are reshaping the future of AI. Let's begin. #1. Helios, real-time, 14B parameter video generation, the end of the speed-size trade-off. Imagine generating a minute-long cinematic video sequence, a skydiver mid-fall, wind whipping past, clouds streaking below, in real time, on a single NVIDIA H100 GPU at 19.5 frames per second with 14 billion parameters. That's not a dream. That's Helios. For years, video generation has been trapped in a cruel paradox. Scale brings realism, but realism kills speed. Larger models drift, flicker, repeat, and collapse over long sequences. Most fix this with hacks, self-forcing, keyframe sampling, error banks, but these are band-aids on a broken foundation. Helios doesn't patch the problem. It rewrites it. Instead of assuming perfect inputs, Helios teaches the model to expect imperfection. During training, it deliberately injects noise, blur, exposure shifts, and motion artifacts. The model learns to stabilize itself, not by avoiding errors, but by mastering them. But how does it stay fast? The answer lies in collapsed memory, a 3-tiered compression system that drastically reduces computational load. Short-term memory, full-resolution context for the last few frames. Mid-term memory, lower resolution, compressed representations of recent motion and layout. Long-term memory, sparse, semantic-level signals, just the what and where, not the how. This isn't just pruning. It's structured compression. The model applies smart filters that reduce the number of tokens processed by up to 8x, without sacrificing coherence. And for inference, Helios uses the Pyramid Unified Predictor Corrector, PUPC. It starts with a low-resolution sketch, motion vectors, object layout, camera path, all in one step. Then in just 3 refinement stages, it layers in texture, lighting, and fine motion details. No KV cache, no causal masking, no quantization, no iterative refinement loops. Just 3 steps to go from concept to cinematic reality. The results? A dragon soaring over molten lava, lava flow, heat haze, wing flaps, all consistent. A man walking through a neon-lit Tokyo street, rain on glass, reflections, ambient glow, no flickering, no drift. All at 1440p, 19.5 FPS on one GPU. This isn't just faster. It's a paradigm shift. It proves that scale and speed aren't enemies. They can be united through smart architecture. And with open-source code and models released, the era of real-time world modeling has officially begun. #2, DLLM, the unifying framework for diffusion language models, the PyTorch of diffusion. Now let's shift gears into the quiet revolution in language AI, diffusion language models, or DLMs. Unlike autoregressive models that generate token by token, DLMs diffuse the output, starting from noise, iteratively refining a sequence in parallel. They're faster, more controllable, enable parallel decoding, and they're gaining traction. But here's the problem: the field is fragmented. Different papers use different trainers, different inference APIs, different evaluation protocols. Reproducing results? Nearly impossible. The research cycle is broken. Enter dLLM, an open-source modular framework that unifies the entire DLM lifecycle, training, inference, evaluation, into one seamless pipeline. It's like the PyTorch of diffusion language modeling. dLLM introduces 3 core abstractions. Trainer, swap between masked diffusion MDLM and block diffusion BD3LM with a single line of code. Sampler, plug in any inference strategy, fast, edit-based, or custom with one sample, call. Evaluation, reproduce results down to the exact hyperparameters. We've matched LLaDA and Dream within 0.1% on key benchmarks. But the real breakthrough? Model conversion. You don't need a new architecture. You don't need continual pre-training. Take BERT, just 2 changes. 1. Set right shift logits equals true. 2. Wrap your data with prepend BOS wrapper. And boom, you've got a diffusion language model. We trained modern BERT-based chat v01, and it beats GPT-2 on standard benchmarks. Even surpasses Qwen1.5-0. 5B chat on BBH and math in just 10 epochs on 8 A100s. Now take Qwen3-0, 6B. Convert it to a BD3LM model using only instruction data. It surpasses the original on human eval and MBPP. This isn't just a toolkit. It's a new standard. With full checkpoints, training scripts, and a hub on Hugging Face, dLLM is lowering the barrier to entry so researchers can focus on innovation, not infrastructure. The future of language generation isn't just autoregressive anymore. It's diffusion-based, parallel, and unified. And dLLM is making it real. #3. Omni-Lottie, end-to-end vector animation from text, the future of design. Now imagine describing a scene. A girl on a rowing machine, green suit, red pants, pulling the handle, smooth motion, realistic fabric movement. And getting back a smooth, editable, resolution-independent vector animation in under 30 seconds. No rendering, no pixelation, no keyframes, no templates. Welcome to Omni-Lottie, the first end-to-end framework to generate high-fidelity vector animations directly from text, image, or video. Why does this matter? Because vector animations are the gold standard for web, mobile, and UI design, infinitely scalable, lightweight, and fully editable. But current tools, they're either template-based, manual, or generate rasterized outputs, non-editable, resolution-bound, and hard to tweak. Omni-Lottie's breakthrough. The Lottie tokenizer. Instead of treating Lottie as a JSON blob, it reimagines it as a structured programming language for animation. Each animation command becomes a token. CMD shape for shape changes. CMD rotate for rotation. CMD scale for scaling. CMD animate for motion paths. This transforms the representation from unstructured JSON to structured tokenized code. The result? 3 times compression, from 2,562 tokens down to just 486, while preserving full vector fidelity. To train it, we built Lottie 2M, 2 million professionally designed, cleaned, normalized, and multi-granularity annotated Lottie animations, using Qwen2, 5VL for description. Then we created Lottie Bench, a standardized benchmark with real and synthetic data. The results? Omni-Lottie outperforms all baselines. 88.3% success rate in text to Lottie. 93.3% in text-image to Lottie. Highest PSNR, SSIM, and Dino scores in video to Lottie. Open source models fail. Commercial tools take minutes and collapse on abstract shapes. Omni-Lottie. Under 30 seconds. Over 90% success. User studies confirm it. Highest rankings in visual quality, motion smoothness, and geometric fidelity. This isn't just faster. It's smarter. By rethinking data representation, building a tokenizer that speaks animation, we've unlocked true end-to-end vector generation. The future of creative AI. From concept to vector animation in seconds. And with datasets, code, and models released, the next generation of design tools is already being built. #4. Decoupling the fidelity horizon gap, a new paradigm for long-form video. Now let's tackle the ultimate challenge, long-form video generation. You want a full-minute cinematic sequence, consistent characters, evolving scenes, lifelike motion. But here's the truth, long videos aren't just longer short videos. They're a different beast. The problem? The fidelity horizon gap. Train on mixed-length videos, short clips, and long ones, and the model averages out the high-frequency details. The result? Long videos with soft textures, blurry motion, and loss of realism. So what's the fix? A radical idea: decouple the problem. Enter mode-seeking meets mean-seeking, a dual-head framework using a decoupled diffusion transformer. Mean-seeking head, trained on a few hundred high-quality long videos. It learns global narrative structure, long-range consistency, causal logic. Mode-seeking head, not trained on long videos. Instead, it aligns every 5-second window of the student's output with a frozen expert short video teacher, a pre-trained model fine-tuned on web-scale data. But here's the twist. It uses reverse KL divergence, not to average, but to hunt for the highest fidelity modes. And to prevent conflict, the two heads are fully decoupled. Only their respective signals flow through. Add inference. Discard the mean-seeking head. Use only the mode-seeking head, now a few-step sampler, fast and efficient. The result? Minute-long videos with sharp motion, crisp textures, and narrative coherence. No drift. No identity swaps. No scene collapses. Ablation studies prove it. Remove dual heads. Performance plummets. Remove SFT. No global structure. Remove sliding window DMD. No local realism. Together, they create believable long-form video, not just longer but smarter. This isn't just better quality. It's a new building block for world models, interactive storytelling, and controllable animation. The dream of AI-generated cinema. It's no longer science fiction. It's here and it's fast. #5. ADE Coty, AI that edits images like a detective. Finally, let's talk about image editing. You ask, make me look 10 pounds thinner. The AI generates 50 versions. Tries to find the best one. But it's wasteful. Every extra image costs time. And money. Enter ADE Coty, a smarter, faster, smarter way to edit images. It's not about generating more. It's about generating better. Here's the strategy: adaptive filtering. Early stage, conservative filtering, only reject obvious fails. Late stage, dynamic filtering, throw out anything that can't beat the current best. Why? Because early previews are noisy. But in the final steps, if it looks bad, it probably is. And the upgrades? 3 game changers. 1. Adaptive sampling focuses more on hard edits, like changing facial structure or clothing. 2. Early filtering with smart verifiers checks if the edit actually happened. Is the book in the hand? 3. Instance-specific verification. The real breakthrough asks targeted questions about the edit region. And then comes depth-first opportunistic stopping. Generate candidates one by one. Check each with a two-stage verifier. If all answers are yes, stop. No more generations. The results: over 2x speedup on Flux 1, Bagel and Step 1x edit. Better quality, and caught errors the others missed. One model went from 678 to 638 steps, 10% fewer calculations, better results. It's like a detective. Early gather clues. Late use strong evidence. Final ask the right questions. No assumptions. No waste. Just precision at the pixel level. And the implications. This framework could revolutionize video editing, multi-turn conversations, even scene generation, all while being incredibly efficient. So what's the big picture? This week we've seen a unifying theme: smart design over brute force. Helios proves that scale and speed aren't enemies. They can coexist through collapsed memory and pyramid prediction. DLLM shows that standardization accelerates innovation by unifying training, inference, and evaluation. Omni-Lottie reveals that rethinking data representation unlocks new capabilities, turning Lottie into a programming language. The long-form video framework proves that decoupling solves fundamental trade-offs, separating global structure from local realism. And ADE Coty teaches us that efficiency is intelligence, knowing when to stop, when to question, when to act. The future of AI isn't just about generating more. It's about generating smarter, faster, and more meaningful. And if you're building the next generation of tools, this is your starting point. So if you enjoyed this deep dive, hit like, subscribe, and let me know in the comments. What kind of AI-generated video, animation, or edit would you want to see next? Because with tools like these, the only limit is your imagination. Until next time, keep questioning, keep creating. This is Collapsed Latents. See you in the next one.